Yeah, welcome back to the Stormworks Basics tutorial. So in this tutorial, I'm going to go ahead and do a little steam piston tutorial here. So let's start building here. So I've been doing a lot of testing today, working on my locomotive, and so I have it in the locomotive bay here. Just this will just kind of show you a little bit of the compact nature of it. So there's a couple interesting things that I and others in the community have kind of learned over the little time, the week since we've had these pistons. And so let's start building. So essentially what I'm going to do is I'm gonna use a generator to show what the final pistons, what the final output is going to be. You don't have to hook it up to a generator and do an electric system. I would, recommend if you're doing a train to convert it to electricity just for ease of use. But you could hook this to a prop shaft, you could hook this to whatever. But at the end of it, I'm going to show a generator just so you can see S watts. So I'm going to go ahead and I'm going to bring in some steam pistons here. I'm going to use the mediums. That's just what I've been using. So I'm going to go ahead and do that. And I want to orient these so that the steam in is all on one side. All right. And so what you want to do is you want to have these balanced. So what I'm going to do is personally, I like a 6. And the reason I like a straight 6 is the same reason that I like a straight 6 diesel motor, is they're primarily and secondarily balanced. And so you can, now this is more like a 2-stroke than a 4-stroke, but you can kind of use the same principles you get with a 4-stroke diesel to get these kind of in balance. And so first thing I like to do is I want to make sure all my steam ends are on one side. This is important. Sometimes this gets screwed up. So as you can see, all my steam ends are on one side. All right, now let's set the pistons. So in a 6-cylinder 4-stroke engine, you have balance where you have 2 pistons moving in essentially the same pattern. This is more like a 2-stroke system. So you essentially have, it's actually not even that, but you have automatic valves in these, so you don't have to valve them. That was the original concept they were going to do, where you had to manually valve them. They made it so they have automatic valves, so you don't have to valve anything. So let's start by just connecting these. Let's go ahead and set the pistons. So in a diesel, in a 4-stroke diesel, when this piston is all the way up, this piston is going to be all the way down. And so let me bring up a quick inline 6 diesel. You can kind of see what I'm looking at. And so this is how I kind of visualize this to understand what I wanted. All right, and so let me bring this up on screen here. And if you look at the firing order here, you can see now, of course, this is a 4-stroke, so you're going to have like if we watch one of the cylinders, you can see that's right there. That's intake, compression, combustion, exhaust. Now we don't need all that. We're not making a diesel here. We're making a steam. So if we go back and let's actually look at this really quick. So you see the outside two, as you can see, they're balanced. They're on different strokes, but they're balanced. And this is why you say an inline 6 is primarily and secondarily balanced. Is that you notice these two move together, these two move together, and these two move together. And so I like that pattern on my pistons for the steam system. So I'm going to do that here. So what I'm going to do is, now with a 6-cylinder, the piston has a max stroke of 5 and a minimum stroke of -5. Negative 0.5 giving you a max complete stroke of 1. So what you really should do is take 1 divided by 6, and I think that's like 0.166 repeating. But you'll notice I can't do decimal places. I can't do more than that decimal places. So what I'm going to do here is I'm actually going to set this to 0.48, and I'm going to set this one to negative 0.48. Next here, I'm going to take half of that. All right, so that would be 0.24, and this one would be negative 0.24. So that's half of 48. Where are we at here? There we go. All right, so these two here are going to be positive 12, which is half of 24. And this one's going to be negative 12. All right. And so these are in balance. So if we look really quick, you'll notice, see how they're in balance? All right. And if we look at the shafts, you'll see these both are down on opposite ends of the stroke. This one's out this way, this one's the opposite direction, this one's out towards us, and this one's away from us. So that's balanced, and that's what we want. All right, so next thing, let's just pipe this up really quick. So a lot of people are going to tell you you don't need condensers. You don't. But a lot of us like RP, and a lot of us are going to want condensers. So let me just turn symmetry on. I can do these T pieces here. All right, so I'm going to try to do this quick and make this basic here. All right, and let's go ahead and we'll connect these like so. All right, so again, I'll say again, you do not need to valve these. The devs have set automatic valving. You don't need to do that. All right, I'm going to take symmetry off, and on this side, so these are your outflows. So this is where your steam is exiting. Okay, so what I'm going to do here is I'm going to connect them like this. And then at the end here, I'm going to combine them, and this is going to go to a condenser. Again, you don't really need a condenser, but for RP, you may want it. I want a condenser for RP, so I'm going to put a condenser on there. All right, and so let's go ahead and we'll put this on for a condenser. Actually, where am I going to put the condenser? Let's put it on this side. I'm sorry, let's do it on this side. This way, I'll just keep this a little bit more compact doing it this way. You'll see why when I get there. That way I just don't have to stretch the pipe so far. All right. All right, and you'll see how these all connect up in a second. So this is all your steam coming out of the system. As you can see, it said steam out. So this is where the steam exhausts out of the piston. So essentially, if you don't understand how a piston works, you have a shaft here, right? And the shaft is coming up, and there's a flat plate. All right. So now imagine the flat plate is right in the center. If I put steam in the bottom, right, it's going to come in here. It's going to expand. It's going to push that flat plate up. That's going to cause this piston to be drawn in, bringing this up on the crankshaft, and it's going to pull on the rod, bring up the crankshaft, and rotate. Then once it gets to the top, this valve is going to close. This one's going to open, and it's going to push steam this way, and it's going to push the piston back down. Okay, so real simple how a piston works. All right, so now let's get the actual firebox going here. So you have to maintain a boiler at a certain temperature. If your boiler gets too hot, you're going to get flow problems. This was something that took a little bit of testing for me to figure out. So you want to be very cognizant of your temperature. So on this side I have steam out. On this side I have water in. This side I have coolant A and B. All right. I like to have a pump on this, so I'm going to pump it. Okay, so we're going to add a pump. And let's see, how do I want to add the pump? All right. And we'll just put the pump. No, that's going to be in the way. Okay, let me just put it right here. We'll make it simple. I'm not going to try to address this up too much. All right, so we're going to connect this pump to the steam. All right. All right, so that's going to go to this large pump. That's going to just help us maintain flow. We may not even really need it, but again, I like to have the pump on there. It's going to help us maintain flow, and that's going to, hopefully keep any issues at bay. All right, and so we're going to go down with a pipe section here. We're going to connect our steam to the steam inlet side. So that's the steam inlet side here. And I'll just go ahead. I'm going to paint all this white. I'll leave the boiler a dark color. Okay, good. So that's going to be steam's going to come out of our boiler. It's going to go in. It's going to go in our system here. And I need to connect this to the top here. All right. Where are we here? There we go. So find the pipe that we need here. All right. And then we'll connect this. So we want to connect these top and bottom. Again, they automatically valve. It looks like initially the devs wanted it to make it so that we could valve it. And then it was changed so that it auto valves. So it makes it a little bit easier, a little bit more approachable, I think. All right, so next thing, we want to do a firebox. Now, we have to maintain a proper temperature for the boiler. I'm going to use a small firebox, and part of the reason I'm using a small firebox is I don't want to make too much heat. All right, if I make too much heat, and if you notice I have 4 blocks between these two, you may not need it this far away, but I have it this far away just to make sure that I don't over-temp my boiler. I had an issue where I was using a large firebox, and even if it was quite a few blocks away, I would set this boiler to only go up to, say, 115 degrees, and because the firebox was too close, it was over-temping this. So I'm actually going to put a temperature control system on both parts. That will give me redundancy. Redundancy is essentially you have multiple systems that do one thing so that if one fails, the other one takes over. And so it's always good to have a redundant system. So now we're going to hook our coolant up. And so what this is going to do is this is going to take water from our boiler and it's going to send it into the firebox to be heated. So it doesn't really matter which direction you go. It's just labeled A and B. As long as as long as they connect to one another is fine. And then what I'm going to do is I'm actually going to valve these. Okay, so these are going to get a valve. All right, and I'll show you why in a second. Okay, so those are valved. Now we have 2 things here. We have exhaust and we have air. So let me take off symmetry. Actually, I'll leave it on for 1 sec. All right, so we need, let me do this really quick. Let me just, real quick, I'm going to put a coal. I'm going to put, let's see, medium hopper on top here. And I'm just going to sit this medium hopper on top of the, that is huge. Sit this medium hopper on top of the firebox. All this is going to do is it's going to give me a lot of coal so I don't have to refill it. That's the main reason I'm doing that, is so that I don't have to refill the coal. And, this can stay up and running for a little bit before you need to feed it. All right, so we have 2 pipes here. This, I believe, is exhaust on this side. I'm going to check it really quick. That's exhaust. Okay, so next thing what we're going to do is I'm going to take off symmetry here. Exhaust is simple. Exhaust needs an exhaust on it. An exhaust and or fluid port or whatever you want. On this side, what I'm going to do is I'm going to valve this too. And this is how I'm going to modulate the temperature of the boiler. I don't need this to burn hotter than, it is essentially necessary to make steam. So you can do any sort of fluid you want. I'm just going to use an air filter. All right, so that's going to tell me that. Now I have a valve on here. Okay, so that's good. All right, so what we're going to do, let's kind of talk through this. So coal is going to go into the furnace. The furnace is going to burn the coal. All right, water is going to circulate from the boiler. It's going to go into the firebox. It's going to circulate through and back in. So the water is cooled off, goes through, it's warmed back up in the firebox, it comes back in, and that gives you temperature in your boiler, which is going to help you make steam. All right. Next thing we're going to do is we're going to put some water on here. So I'm just going to do a tank. And you don't need a big one. I'm just going to do a medium tank here. All right, so that's, again, it's nice that we have this pass-through now. So next thing I'm going to do is a condenser. And I'll just color the condenser this color again. Okay, so now what we want to do is we want to take in... we want to take in, I'm going to move it so it's in line with this pipe here. So we want to take in steam in, and that steam's coming in from here, right? So all the steam exits the pistons, and then it pushes this way, and it's going to go into the condenser, okay? On this side, we need to connect a radiator. All right, now it's going to cool this off. Try to get this lined up here. Okay, and I'm just going to grab it and line it up. All right, so that's lined up. All right, so that radiator is going to cool our condenser. That's going to take the hot steam and condense it back into water. Now, some people can tell you don't need a condenser, and you may not. But for RP reasons, IRL, you would need a condenser. The steam needs to be turned back into water. You know, water is not an infinite resource. You need to recycle it in order to, you know, make more steam, or else you're going to run out of water. In game, it's going to be different. So again, yes, people might tell you don't need it. For me, RP-wise, I like to have a condenser on there. So again, you may not need it, but I'm going to put it on there. And if they ever change it where you do need it to make it more realistic, it's good to have it on there. All right, so we'll talk through the system really quick. Heat up the water, cycles through the firebox, is heated, goes in the boiler, creates steam. Steam comes out, goes through this pump, goes up, it goes into the pistons, valved automatically. It's going to rotate the shaft, giving us torque. All right, the steam is going to exit on this side. It's going to come through the condenser where it's cooled down, therefore turning back into water and recycles. Okay, perfect. All right, so next thing we want to do, let's set up our valving system. Okay, so let's do a blank microcontroller here. And I'm going to set up a temperature regulation system here. All right. All right, so here's our temperature regulator. So we need to start adding some nodes. Okay, so we're going to start adding some nodes here. And first one in is going to be a number input, which is going to be boiler temperature. Okay. There's going to be an output, an on-off output. That's going to be boiler valves. Okay. We're going to have another number input. That's going to be furnace temperature. And then we're going to have an on-off output. That's going to be furnace air. All right. So let's go into the microcontroller. So now, these temperatures I arrived at through experimentation, so you can play with them if you want, of course, but I've already kind of done some experimentation, so I'm going to use these. So if the boiler temperature is less than, in this case, I like using 115. If you get over 120, you start to have oscillations in your fluid flow for your steam. The oscillations are going to cause your pistons to not work properly. So you don't want your boiler to get over about 120 degrees. So 115 is about as high as I go on that. So if the furnace temperature is less than, and we're going to put a constant number here. Actually, let's do a property number. Okay, property number. If the furnace temperature is less than, and we're going to do 115 degrees. We want to open the valve, and that's going to cause hot water to come in and cycle through the furnace. That's boiler valves is where that should go. It's going to allow the valves to open and allow the water from the boiler to go to the furnace to be reheated, so to keep it at 115. Now we could do this with a PID, but we're going to do it really simple with an on-off. Furnace air, if boiler temperature is less than, I could have copied that one there, but I didn't. And then in this case, what I'm going to do is we'll do another property number here. If it is less than, and what I like to do is just 200 degrees. 200 degrees is going to be hot enough that it's going to easily and quickly boil our water. And so what that's going to do is it's going to open the valve if it's less than 200. And what it's going to do is when it exceeds 200 degrees, it's going to close the valve, choking off the air to the furnace, therefore letting it essentially slow down and cool off. All right, it's pretty simple. Let's go in here and let's start connecting that. So we want boiler valves. Boiler valves are these two valves here. You could probably do it with one valve, but I just decided to do it with two. Furnace valve, we can just do one. So this is your furnace temperature. You want to go to your Firebox and grab that. You want the temperature of the boiler and hook that to boiler temp. Pretty simple. And I'm just going to move it so that it's sitting on top like that. All right. All right, so that's connected. So what this is going to do is As this gets cooler than 115, it's going to open the valves and let the water reheat. When it exceeds 115, it closes the valves, making it so the water doesn't go up any higher than 115. When this furnace goes over 200 degrees, it closes the valve, choking off the air supply, causing that to cool off. And then once it gets back down below 200, opens up the valve, lets it breathe again. All right, pretty simple. All right, so now let's work at our actual power takeoff, our torque here. All right, so let's understand the thing about these pistons. So these pistons are low RPS, high torque, very high torque. These have a lot of torque. All right, so you essentially need to convert your torque to RPS. All right, how do we do that? Gearboxes. Gearboxes are very simple. Let me bring up a quick. I'll bring up a quick Google Drive, and you can see. I'll show you that the math is uber simple on how to do gearing. People often struggle with gearing, and I'll just make a very super fast spreadsheet, and you can see how gearing works. All right, so very simple. Gears are essentially fractions. So we'll do G1, G2, G3, G4, G5, and we'll start with that. Okay, so now let's go. We'll do 3 ones. That's just going to be our 3-to-1 gear ratio that we'll set. And we want the arrow pointing towards the pistons. That's going to multiply the effect. All right, so now let's do a little math. So we'll do total GR. All right, and so this is going to give us our total gear ratio there. All right, so now let's do a function. So we want to do equals. All right, I want this times this, times this, times this, times this. So essentially all you're doing is multiplying fractions. All right, and then I want, put it equals there, equals this times this, times this, times this, times this. Okay, now I could have just hit enter, but I decided to go through it anyway. So that's a 243 to 1 gear ratio. So 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. All right, so that's how that works. Now, that's great and easy, because if I change this to a 9.5, we have a 729 to 5. Okay, so now that's total gear ratio. I want to put final GR, because this doesn't really tell us much. So what I want to do is I want to take equals this divided by this. And that gives us a final gear ratio of 145.8 to 1. So that gives us our final gear ratio. So if our gear ratio was too high, let's say we're at 243 to 1, and we want to reduce that, we can go to maybe one of them will be a 9.5. That's 145 to 8. If, let's say we want to make this a 2 to 1 gear ratio, that's 162 to 1. Okay, so that's how we can set this up. So I'm going to stick with this. I know this works. That's a 243 to 1 gear ratio. So that means for every 1 rotation of the pistons, the crankshaft on those pistons. Now remember, very low RPS, very high torque. So it's going to rotate very slowly, but it has so much torque that we can get up to 243 on this side. All right, so we're going to go ahead and put that into practice here. And so I will go ahead and start spamming some gearboxes in here. So we used to have to worry about breaking the gearbox, so we don't have to. Let's put the arrows facing towards the crankshaft here. And what do we have? 5, I think we had there. Let's see. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. Yep, so that's 5. 1, 2, 3, 4, 5. I put 6. Okay, so that's 1, 2, 3, 4, 5. That's 5 to 1. 5 gear ratios. So let's go 3 to 1 on all of them. That's going to give us that 243 to 1 gear ratio. So again, for every 1 rotation of this crankshaft, we're going to get 243 rotations of whatever we attach this to. All right, now I'm just going to take a generator. In this case, a large generator. You'll see how much electricity we can make with this. And so, you could direct drive this. You could hook this to a boat's propeller. You could hook it to whatever you want. But this is just a good representation to show you how much electricity you can make. And therefore, if you want to do some electric drive, or you want to hook the end of this to a propeller, that works too. You'll actually get good speeds with this too. I think we're turning somewhere in the neighborhood of 34 RPS, something like that. Maybe less. I think I have 6 gear ratios on my 6 gearbox on my train. Okay, so let's go ahead and get this plugged up here. So I want a toggle button. And so this toggle button here is going to go ahead and it's going to control a bunch of stuff. So this toggle here is going to turn on my pump. This toggle is going to turn on my radiator. This toggle is going to turn on my ignition for my coal. Once you've lit the furnace, the only way to shut it off is by choking out the air. All right, and yeah, so let me actually make an extra node here. I'm going to make an extra node here, and because we'll never be able to shut our furnace off if I don't. So I'm going to go ahead and add a node, and that's going to be input system on toggle. Okay, and so what that's going to do is I'm just going to add this in here. So in order to get furnace air, it needs to be less than that, and this button has to be on. That's going to make it so that when I shut the toggle off, it will actually shut the furnace off. Currently, if I shut the toggle off, it's not going to shut the furnace off. So I want to make sure it shuts the furnace off when I shut this toggle off. There we go. Okay, so I need the system toggled on, and I need to be less than 200 degrees to not choke out the furnace, essentially. All right, and we will add this to here. All right, so now you'll see a lot of people, they'll throw the biggest battery they can put in. Now, theoretically, if you have a small battery, you can run anything. You could run a giant ship on one small battery if your electrical generation system is precise enough, because, you know, for every, let's say, 0.001 S-watts you lose out of your battery, if this is putting 0.001 S-watts back into your battery, you can run a huge vehicle off of a small battery. Now, I'm not going to. I'll throw a medium in here. But you can, you theoretically could easily put just a small battery in there if you wanted. All right, so I'm just going to direct connect. I'm not going to connect to any of these gearboxes because I'm not changing any gear ratios. All right, and then let's hook up all the valves. All right, so let me just do a quick look, and I think we should be set to go. Let me make sure there's a toggle button. It is, okay. System on. Okay, and it starts in the opposition. All right, so let's start this up. All right, now I have no clutch on this. It's just gonna, you know, I could put a clutch on here. I could modulate it. I could unload the system. Not gonna do any of that. System's coming on, so let's see what it does. So the furnace is turned on. You notice the temperature is climbing. Ignition is true. We look at our valve here, our valve is open because both the system is on and we are under 200 degrees. All right, if you look here, our valves are, let me see, something's wrong with this. Valve false. Okay, these valves should be true, so something's wrong. All right, we want those valves open. They're currently closed. Let's see what's up. I must have hooked something up backwards. All right, so let me look. All right, where are we at here? Boiler valves. If the furnace temperature is less than 115 degrees, boiler valves should open. Okay, that's because I have the furnace temp, so it's hooked up incorrectly. So this should go there. This boiler temp should go there. Okay, just hooked them up wrong. So the boiler, if the boiler is less than 115, desired boiler temp. I just labeled everything wrong. Okay. If the boiler temperature is less than 115 degrees, it opens the valves. If the furnace temperature is less than 200, and the system toggle on, it will open up the air for that. So that's fixed now. All right, let's go turn the system on. All right, so valve should be open. Yep. Ignition's true. We're starting to build temperature and burn. These valves are now open, which is correct. You'll notice we're climbing in temperature. We don't need pumps. This is auto-cycling the water through. You know, they've finally got wise and put integrated pumps. Let's make sure this is true, which means it's on. It is. You'll notice we're losing electricity. That's because we're running a pump here. Condenser is over there, and we have a radiator pumping on this side here. So we don't have any water running in this, which is fine at the moment. All right. All right, so our building temperature takes a little while. You know, I recommend, I tried doing some a lot of my train building live, where I was building my system on the train. I would recommend doing a test bench like this, get your system set up, and then port it over in. That way it's going to help you. So, like I was saying before, I had a large furnace. If the large furnace is too close to the boiler, what's going to happen is the ambient heat from the furnace is going to overheat the boiler. You want your boiler, I would say, no higher than 115. Once you hit 120, what you'll notice is, okay, so see we just hit 100 degrees Celsius. Notice the pressure's building. Look at the bottom. You see our steam's going up. Our steam is coming out. See how we have a nice static number? That number is not oscillating. It's climbing, but it's not jittering. Let's find a number that's jittering. See how that's jittering around? And it's, you know, that's because the valve's opening and closing. We want our number to be nice and stable. If we get over 120 degrees, we're not gonna be nice and stable. All right, so now that we're over, let's watch this system work. So see, watch the temperature. See, it goes 114, 115, 114, 115, 114, 115. The reason it's doing that is watch our valves. Open, close, open, close. Now, a more complex system would use a PID and a variable valve where the valve would open just enough to always keep the temperature there. You know, I'm not going to go into that complexity. I'll eventually put that on my systems, but this open close valve is perfectly fine. Same thing with this. You'd want to open this just enough to keep the temperature at around 200 degrees. It doesn't have to be 200, but that's just the number I picked to make sure that I adequately can heat my water. I tested it, it worked well. All right, so now let's go over here and look. Now remember I said these are low RPS, high torque. Look at the RPS. 0.38 is our RPS on there. All right, so we have nice low RPS. The gearboxes allow us to convert this 0.38. That's going to multiply that by 243 times, and what do we get? We get 36 RPS. If we turn a large generator at 36 RPS, we get 1400 S-watts. So this simple system here is making 1400 S-watts. So this is a very powerful system. Now these aren't even large pistons. You go to large pistons, you're going to get even more. Let's watch how these are balanced. All right, so again, this is based off of you know, a 6-cylinder diesel. These two are in balance. These two are oscillating in opposition. These two are oscillating in opposition. We get a nice, nice wave pattern here. And as you can see, our multiplication on our different gearboxes, you have 15.15 RPS, which is what it's at now, going up to 45, 45 to 126, 126 to 375, 375 to 11, and then 11 to 32. So you have enough torque in here, you could probably keep going. All right, so we have a pretty stable system here. Now we need to watch our temps. All right, and so see we're keeping a nice 15 there. We have a nice 9 liters per second. We have a consistent number there. All right, now if you wanted, you could put a keypad and change your desired boiler temperature. It's up to you. All right, but just kind of a simple proof of concept. Sure, infinite electricity is off. All right, so let me check on the side here. And I want to check my water. Might have some issues with water here. All right, so see, we're not getting any coolant value here. Let me check my coolant. So I think we're running out of water. That's probably why we have, you notice we're losing power. That's probably a water issue. So let me go ahead and look at that. You'll notice we're losing S-watts. That's probably a water issue. We're not getting our water back. So let me try to address that really quick. All right. We should have, we want good flow with coolant. Cooling is often about good flow. The other thing too is ambient temperature. We want to make sure we're not too hot here. I'm just trying to find a good place to put these. Here, let's just do this. So I'm going to put some pumps on this. I want to make sure I'm cooling. I'm actually not cooling and condensing, so I need to make sure I do that. So let me do this real quick. Let me check with the direction of these. A and B, it doesn't matter. That's what I thought. All right. And this just needs to pump. Just needs to pump one way or the other, like that. And I'll cut this. Make sure that's where I want it. That's oriented correctly. Okay, let's stick it on top. Okay. And let's see if I can get this to cool properly. So we're going to go to our systems button here, and we're also going to power these. Let's check our electricity as well. All right. And let's get this, make sure this is cooling properly. In my system on my train, I use a very large water capacity, so you might have to increase water. Diesel. That would be why. I need to make sure this is set to water. I know my system on my train is set to water. Might not even need to do what I just did with the coolant, but I don't think we needed those pumps, but let me check it. Should be getting flow. I noticed this earlier. Yeah, see, we have perfect flow now. Let me actually test this really quick. I forgot to set that tank from diesel to water. That's why we were starting to have issues, was we were not cooling our water off. We ran out of water, essentially. Let me just quickly do this. Trying to keep this as basic as possible, so I don't want to have extraneous parts that you don't need. I'm kind of, a lot of people throw pumps everywhere, which is fine. But if they're not needed, you're just wasting a lot of electricity or wasting a lot of space. And if you're trying to do something in career, it costs you a bunch of money. Okay, so I do need those. I'm not getting any flow. Let me check this really quick. Okay, let me just throw that back on. I know it's kind of annoying me putting them on and off, but I need to just verify if I need those pumps or not. So. Looks like I may need them. Okay, put the pumps back on, one up, one down. Doesn't really matter which way, just need to be in opposition like that. All right, we'll merge that and we'll rehook these to both electricity, and we'll hook them to the systems button there. All right, let's give this a spin. And I'll make sure my water doesn't run out here. Let me check the water capacity on that. Okay, so all the water is in the system. All right, so see we have fluid in, 75.3 liters, fluid out. We have a nice consistent flow there. Temperature's rising on that. All right. The one thing that it just takes a little time to get this started up. As you can see, we're just building temp here. We need to get this up over 100 degrees before you even build any steam. So that's kind of what we're waiting on here, is we're waiting on that to build steam. If you're going to do direct drive, or say you're driving a propeller, all you need to do is put the end of your gearbox. This is your output shaft here, post gearbox. You put that into a clutch. You can put it into a final gearbox that will either reverse or make your prop go forwards. Same with if you want to do a land vehicle, you can do the same thing. Or if you want to do an electric drive system like this, you can. Alright, so let's see. We're just about to hit 100 degrees now. You can test how high you want the boiler temperature to go. Again, once I hit around 120, I start losing consistency. You see how that leveled out? Now it's giving me a nice consistent. The number's not jittering around. It's not doing what this is doing, where it flickers. It's nice and stable. That's going to give me nice and stable steam flow, and that's going to give me nice and stable piston movement there. And we're back up around 1400 S watts. Let's watch this for a little bit just to see if it behaves itself. Might want to put a pump to draw steam out of this system. Might do that. Alright, so as you see, we have consistent steam. One thing you'll notice, which is perhaps counterintuitive, if your pressure gets too high, you start getting oscillations in the in your steam, and that's what will cause your system to start having problems. Oh, nice, consistent 1400 S-watts there. So again, look at our battery. Our battery is now sticking at 1. I'm able to take a train with 1 medium electric motor at full throttle, no problem, and I don't lose any electricity with this system. Again, you can make this more complex where you add a PID and a clutch so that you can automatically reduce the clutch if you are building enough electricity, and that will take load off of the system here. So that's an option as well. You can further complicate this, of course, as much as you want. That's Stormworks for you. All right, see, we're in a nice, stable 9 liters per second. And notice the condenser now. We have fluid going in and out, steam in, water. So our water is cycled now, so we're actually to the point where we're cycling. Look at the temperature. As you can see, it's going 80, it's going 70. So the condenser is working. So it took a while to get enough steam in there to condense. All right, look at our water in. Our water in is at 0.1 liter per second. That's coming from our condenser. Let's go back around the other side. Tank, as you can see, is at 0.1 liters per second. Now, you remember it was showing 0 for a while. We needed all the steam to come out of the system, go into the condenser, and condense enough that we are able to recall our water. So this is a closed loop system, as you can see. We should not, theoretically, not be losing any water. As always, when you're moving fluids in Stormworks, you want to make sure, notice how that 78 is not bouncing around, it's not flickering. You want to make sure that you don't have any flickering. All right, so we have a nice consistent, 0.1 liter there. Let's check our S-watts. If we have any issues, where this goes down, that's probably going to be that water flow again. So if you notice your power generation's dying after a while, you're possibly using up all your water, or you're making more steam than you can condense. You're probably going to have to add a larger water reservoir so that you can you can maintain your system. But pretty simple system. I'll end it here in a second. But these steam pistons are excellent for a lot of applications. Again, they're intended to have very low RPS, and very high torque. And all you need to do to convert torque to RPS is gearboxes. If you point the gearboxes towards the engine, it increases the RPS. If you point them away, it decreases the RPS and increases torque. So that's what the arrow is. This takes torque, converts it to RPS. The other way around would take RPS, convert it to torque. All right, and we're still consistent there. All right, so we'll end it there. As you can see, this is a functional system. This will be on the workshop if you want to take this, play with it. If you want to change some numbers, you don't like 115, you can go right in here. You can go in here, you can change that to whatever you want. I'm not going to show you now. It would take like 5 minutes to get it up and going. But if this was 120, most likely that's going to overtemp your boiler. You're going to notice instead of a nice consistent 9 liters per second, it's going to go, 10-0, 10-0, or 10-5. And what's going to happen is that's essentially like adding air bubbles into there, and that's going to cause compression, and you're going to lose any efficiency. If we went down to like 105, you're going to get more like 6 liters per second, and that's going to reduce your steam flow. So about 115 is about where I like to keep it. All right, so this will be up in the workshop. You can use this to kind of guide you if you'd like. If you have any issues with it, let me know. It's early days for these, so a lot of us are still trying to figure out the little ins and outs and minutia of it. I might not even need these pumps, but again, I put them in there just to kind of peace of mind. Probably don't even need this pump, but it's in there just to verify. All right, so thank you for watching. I hope this helps.